All right, good morning, everyone. Welcome back. Day 2 of Jamf. How we feeling? Or JNUC Jamf. I'm from Jamf, but JNUC, day 2 of JNUC, right? We're feeling good? Awesome, very cool. So I'm here to introduce our next session is Apple and Jamf Device Security from the Silicon Up, right? We're all here for the right session, hosted by Katie English.
All right, thank you, T. Thank you, everybody. Thank you for joining me on day 2. Better than day 3 when everybody's a little hungover. So we got to click through the thing. This is Apple and Jamf Device Security from the Silicon Up. I'm Katie English. I'm on the product team at Jamf. This talk is actually a reboot of one that I did back in like 2018 at an Apple office in Chicago. It was a really fun topic. But thankfully, a ton of things have changed since that initial discussion. So basically, this is going to be a crash course on modern Apple security with some really good Jamf flavor thrown over top. And there's no possible way that I could teach you a 370 in 45 minutes or less. But I do have a few goals today. One is to demonstrate the holistic view of device security with Apple and Jamf technologies combined into something that's greater than they are separately. Next is to give you some greater confidence when you're having any challenging conversations with your InfoSec teams about risk and compliance. I know that comes up from time to time with the dreaded spreadsheet of doom. And also, I want to give you some takeaways so that when you get home, you can bolster your own device security with your own systems. So, to kind of frame the conversation, I'm going to be talking about layers of security, and of course that's a pretty common framework, meaning all of the different tools and resources that sort of provide protection to your Apple devices from any malicious people or things on the outside that are trying to mess with you. And in my session description, I called this a security parfait, but having thought about it a bit more while I was preparing for this session, I figured I would probably need to adjust my metaphor. Do something a little less or a little more substantial, if not as appetizing. And since I'm starting with the silicon that actually literally makes up Apple's chips, I figured we're going to go all in on geology and a representation of sedimentary rock. And it also gave me a convenient way to reuse the JNUC location and the theme for the year. So we're going to start off at the very lowest elevations of our mountain range. And we're going to talk about how Apple builds and designs their hardware and software so that you can be prepared with that foundation as we're thinking about all the stuff that we interact with in the OS, and then all of the tools that we layer over top, and ultimately with Jamf management and security tools as well. So we're taking Apple's native and extensive platform security, and we're going to elevate it with Jamf. It's almost like I did it on purpose. And you might be thinking, Katie, I can definitely read the Apple Platform Security Guide on my own. And you're right, you should. It's a great resource. It's 300 pages, so block an afternoon, bring a snack. We wouldn't have any hope of getting all the way through it today. You'll find I abbreviate heavily. But it's actually more than that. It's not the full story for us as Jamf admins. Because we have a lot of additional tools and options to both understand the security posture of Apple devices in our environment, as well as remediate any risks that we might detect along the way. So we'll go ahead and get started. We're at the very beginning of our climb. Sorry, I'm going to abuse this metaphor a lot. And that means we start with the term SoC, System on a Chip, which is the low-level place that we find the secure enclave. What's an SoC? Well, it's just a term for multiple components on a single chip. And the secure enclave is one of those dedicated subsystems. It is instrumental to a lot of the encryption processes that we'll see upward as we kind of add more layers to our security. And you've probably heard of the secure enclave, so what is it? Well, it's a hardware-based key manager, and it's separated from the main processor, and that separation is really quite important because it adds another layer of protection from things like side channel attacks. Because the main processor isn't directly handling private keys, the keys are isolated, which makes it harder to compromise them, even if the kernel itself becomes compromised. Hit the button. There we go. The secure enclave has its own boot ROM, which is immutable code that establishes the hardware root of trust And it has its own OS, and it's subject to its own series of cryptographic checks and validations. So we're pretty much talking about a little computer in the computer that handles all the low-level trust operations of the rest of the system, including various biometric options that Apple offers to allow a user to authenticate to the device without having to type in their password or passcode every single time. But you can see that we're already starting to leave that basic chipset layer behind. These tools and systems aren't isolated, they're foundational, and they inform how the OS and apps process and access sensitive data. I already mentioned the boot ROM, which is written to the device at time of manufacture, and it contains the public key for Apple's root certificate authority, which is then used for verifying the bootloader, which then verifies the kernel and the signatures of the signed system volume, and even kernel extensions, if you're still using those, please stop using those. Then ultimately, we get to the OS. And I've definitely condensed a whole lot about the boot process. But to recap, baked in from step one, processor design for hardware-backed key management that's separate from the application processor, and read-only processes for establishing and validating trust at every boot. Now, a few years ago, Apple added even a few more extra layers to this boot process, specifically the signed system volume. And basically, this seals off the Apple installed software and only allows Apple signed data at runtime. And that signing methodology also applies to software updates. And there's an entire authorization process to ensure that the device requesting the update is permitted to download it. And there's a chain of trust evaluation to make sure that the request and the subsequent update response actually match, basically looking to prevent any man-in-the-middle attacks or interception of the data that might then compromise the target system, or to prevent what's called a replay of an update, where the update is delivered to one system, actually lifted off that system, modified, and then delivered to another system. So in short, we keep building up our layers, which equals more friction for an attacker to get through to effectively compromise your system. And by the way, we're talking about pretty much identical mechanisms for Mac and mobile at this point. But Apple does have additional control that we see most often on the mobile side. And I mentioned that the signed system volume and the update authorization process are all built to ensure only Apple signed code runs. But you might see the occasional tech headline that looks like this. Apple stopped signing iOS. In this case, it was 18.5. This is a pretty common thing that you'll see kind of on the tech websites. Now, it's fairly specific to iOS and occasionally iPadOS. But it's largely about preventing users from trying to downgrade to an older OS that might have actively exploited security vulnerabilities or potentially some other kind of bad thing that they want to avoid. But basically, Apple's reusing their own signing methodology that ensures that the response for a requested software update is legitimate. And by breaking the cryptographic chain of trust for an old update, simply renders that version of the OS unavailable to be installed, and therefore forces the new version instead. I have not, and someone might fact check me on this later, I have not seen this method used on iOS, or excuse me, macOS. But I do expect that Apple could pull the lever if they wanted to. All of this, and we're almost ready to properly log into the device and use it. But just like I had a pretty much mobile-specific security enhancement, I also have a Mac-specific one. And that's System Integrity Protection, which is on by default. And these days, you have to work pretty hard to disable it. It is still possible. But it keeps critical system components in read-only mode, pretty much blocking malicious attempts to modify them. OK, so we've got cryptographic handling at the hardware layer level. We have multiple eligibility and attestation checks. I'm going to come back to attestation in a little bit. We've got OS installation and update methodology that resists tampering. And we've pretty much reached like ground level in our sedimentary rock metaphor here. The OS is kind of up and running, which means that we definitely need our local data to be encrypted. And that's easy, right? File Vault is immediately available on Macs with Intel. And on mobile devices, we're actually using a system called Data Protection. And on Silicon devices, Silicon Macs, we're actually using Data Protection until you actually turn on File Vault, and then we just go with File Vault. So Super easy to encrypt your data at rest. And the keys for the local volume encryption of that data at rest is handled by the secure enclave. Destroying those keys, like in the process of erase all device content and settings, renders the data protected by those keys inaccessible. And that's partly why erasing an iPhone or a modern Mac is so fast now. Some of you probably have PTSD like I do, trying to do a DoD 7-pass wipe, zeros all over the drive. The worst. It's much easier to just forget about how to access the data if the keys go poof. So this is actually a welcome development. All right, we are up and running. Our data at rest is encrypted. I need some apps. So Apple has a number of runtime processes that continuously evaluate the validity of any code that a user might try to run. And on the Mac, this looks like a combination of Gatekeeper, XProtect, and a validation check called Notarization. And these tools work together to ensure that the code that a user might run is run on purpose, that it's legitimate from a legitimate developer, and that it hasn't been tampered with in transit and doesn't contain any signatures of known malware. We've all seen Gatekeeper kind of do its thing, right? You download an app from the internet, you double click to open, and you get this warning. This thing was opened this day and time. What's happening right here is that the app is quarantined. You're actually seeing a real-time effect of an extended attribute applied to the executable by the system at runtime. Don't let this thing launch yet until the user says it's okay. And that's the visible part of Gatekeeper, but what it's doing right this minute is actually contacting Apple's notarization servers in the background to make sure that the code is signed and what's called stapled. Basically, assuming that a legitimate developer wrote the app, the developer sends it off to Apple for a quick scan of malicious code, and when that scan completes successfully, Apple returns a ticket that the developer then uses to staple to the software package with a hash, making it available for download, and assures the end user that this is the untampered with version of the app, that the developer is, in fact, a legitimate Apple developer with a legitimate Apple developer identity, and that they meant to make this available out in the world. Can Gatekeeper be bypassed? Yes, it definitely can, but we're still just talking about layers, about adding friction to the process of a bad actor successfully delivering malicious code to the device and getting a user to actually run it. So what happens if that end user gets duped and actually does try to run something that's not good? Well, now we're talking about XProtect, which is the built-in malware, anti-malware scan that's built into macOS. And it uses a number of different signatures for known patterns of exploit code. And those signatures are periodically updated when Apple discovers some new risk out in the wild. And if XProtect finds something that matches one of those signatures, you'll get a warning that this thing, whatever it finds, will damage your computer, and it'll prompt you to move it to the trash and also to tell Apple that it found something fun. But of course, the wilds of the internet are not the only place to get software. Apple is extremely keen on their App Store and the scanning and review processes that it employs there to provide the assurance of safety from the apps that are made available in that location. Apps from the App Store on Mac and mobile not only benefit from those App Store review procedures, but also from running a runtime security process known as sandboxing. Sandboxing means that apps are prevented from either gathering or modifying data stored by other apps. Basically, stay in your lane. Don't look at any other data that might be on the local volume. And more than that, mobile apps in particular are run with extremely limited privileges on the device, meaning that in most cases, for most users, it's actually pretty difficult to run malicious code on an iPhone or iPad. Not impossible, but difficult. And Apple keeps sort of adding micro layers between a potential bad actor and an end user. And you've probably seen something called BlastDoor in action on your own iPhone, even if you didn't know the name of that specific feature. It's one of Apple's cooler feature names, honestly. It uses sandboxing and Apple Identity Services to reduce the risk of zero-click attacks. And those are those sneaky attacks where an end user doesn't even have to interact with the contents of a message, for example, in order for that message to actually deliver something that could compromise the device. And this combination of processes basically takes a look at untrusted data that might show up in messages, analyzes it, and prevents something bad from reaching other parts of the system. And this defensive feature even prevents you from clicking a link from an unknown sender. But what's super cool is, even if that initial link that you receive is from an unknown sender and looks a little shady, Apple's checks are still happening in the background. So later, if the scammer is actually legit, and the link is maybe less shady than it looks, then Apple might actually just let you click that link later with no additional intervention. It's pretty cool. So constant dynamic checking. And the peak of all of these native Apple security features is the big hammer, and that's lockdown mode. If a user of yours is particularly high profile or you're particularly paranoid, no judgment, and your identity or access credentials would be especially valuable to an attacker, the user can opt in to lockdown mode on the device, and that limits a lot of the convenient and delightful features that we all really like about Apple devices, but it also really cuts down on the risk that that device might pose in regard to unintended code execution or external intrusion. I've also got a couple late-breaking developments here since I initially submitted the presentation. Last month, Apple kind of slid this in. It's pretty cool. They published this blog alongside the release of iPhone 17 and iPhone Air, and it's about memory integrity enforcement built into hardware and software. There's also an enhanced memory tagging extension for Xcode for developers, and will pose a significant barrier for spyware developers on iOS. And Apple claims, and I think we're going to see how this goes in the future, that it inhibits speculative execution vulnerabilities in real time without degrading device performance. So it is the most common way that spyware is going to get you on an iOS device is like basically a memory overrun where there's an intrusion that actually just bumps into a memory space that it's not supposed to be in, which is mostly why spyware on the iOS doesn't survive a device reboot. This is meant to basically stop all of that process from even happening, and again, without degrading device performance. Really cool. We'll see how it goes in the future. The blog is super technical. It's a great read. Maybe put it on your calendar after you read the platform security guide. Another late-breaking thing that is so late-breaking it hasn't actually released yet, keep your eye on the 26.1 release notes when that eventually makes general availability. Mostly because it looks like we're in for a rebrand of rapid security response updates. Now, you'll notice I didn't talk about rapid security response updates at all. It's mostly because it seemed to be a tech that Apple kind of abandoned. I don't think they got the results that they were looking for in regard to that application. But it looks like we might be looking at a rebrand for background updates. So watch this space. We'll see what's going to happen in future OSs, but Apple's always iterating in regard to how they deliver security patches faster, maybe even without a reboot. Okay, so that was a crash course in Apple platform security, and let's take a minute to review where we've gotten to, because we've already built up quite a few layers. First, Apple devices feature robust security right out of the box, with intentional architectural design decisions about encryption and key handling literally baked into the chips. And those choices extend to the actual user experience with every authentication and authorization event. On top of that is an operating system deployment and update model that resists tampering, ensuring that you're running genuine Apple software and applying genuine Apple updates. Further, there are a number of applications and processes built into the OS that are designed to maintain and kind of stay between the end user and any malicious code. And you can look outside the device or the operating system, and Apple has even more options here in regard to remote services. We're all familiar with Find My to allow for things like remote wipe if a device is lost or stolen. And as a little bonus, Apple's hardware security isn't just about encryption or processing. Sometimes it's about straight up preventing access to a feature at an unwanted time. This one's pretty cool. On most modern Mac laptops, the microphone has a hardware disconnect that actually prevents it from being used when the lid is closed, which speaks to the intentionality of the design with privacy and security at the forefront. It's really hard to have a compromised microphone sitting in your bag listening when it's not even connected and available for use. So that's pretty cool. Okay, we've come pretty far. And if I'm looking at my layers of security and thinking about all the benefits built up by Apple's own platform, I'm going to say we're about ground level here in Denver, which is still pretty high above sea level, but we've got more mountains to climb, apparently, if we head west. So we're going to elevate, and we're going to get these devices managed and add some more layers. Up front, you've got some choices to make, and that's represented by a couple colors up there. The act of applying management to a device is either going to favor organizational control and transparency, or it favors end-user privacy by virtue of which method you're using to get that device into management. And if we're talking about an organizationally owned device that's an Apple Business Manager or Apple School Manager, that device gets automatically enrolled at startup, ends up supervised. Of course, you get the most management control available. But real quick, if you haven't spent a lot of time considering account-driven user enrollment for BYO, it is a more limited flavor of management. And the sandboxing that we mentioned for limiting mobile apps from accessing data from other apps, effectively that extends to the mobile or the bring your own management experience here. You can't even get inventory information about the non-managed parts of an operating system in this model. So this flavor of management is heavily indexed toward user privacy, which is good, but might not totally serve your organizational needs, so it's something to evaluate. And just because it's worth mentioning as another management layer that sort of spawns off of Apple Business Manager and Apple School Manager, Apple allows organizations to create managed Apple accounts that have certain capabilities or limitations, depending on what you want to allow your users to do. And that could translate to this user can both have a managed Apple account and they can save documents to iCloud or not. And of course, Apple's invested a lot of time and effort in making the managed Apple account domain capture process a lot easier these days. So if you've got rogue users who are using their work email for Apple accounts, you should probably spend a minute working through the domain capture process to make sure that those accounts get into your management. So management happens on the device, and we get inventory by way of a few methods. We're either going to get binary values from the Jamf binary on a Mac, or an MDM device info query, or declarative status updates, which means that a number of the platform security features that we just talked about, the things that Apple builds out of the box, are now reportable and or enforceable from the management platform, including things like file vault, allowed applications, meaning can I use the App Store or other developer locations? And then also system integrity protection. But this is where I get back to attestation. I mentioned it earlier. And there are a few different contexts under which Apple is verifying signals and identifiers from a device to ensure that it's legitimate. But there's a very specific flavor of attestation that comes along from device management. And you'll see this show up in your device inventory in Jamf Pro. And this is the result of a device information MDM query that includes device properties attestation, which prompts the Apple attestation servers, that's a fun word to say, to do an evaluation based on the device information. Does it match known, verified, genuine Apple hardware with the related identifiers? If so, you'll get success returned. And you'll have another layer of assurance that your devices aren't being spoofed by unknown hardware. And you can add this to your reporting, or you can use it to issue certificates with like an Acme CA. Which brings me to a segue in regard to configuration profiles, which of course are a very common topic. Everybody's quite used to them. Regardless of your certificate infrastructure, you're probably going to be using a configuration profile to deliver that certificate. But of course, configuration profiles let you do a lot of other things. How is this device allowed to connect to the network in general? What restrictions should be enabled on this device? Can it use the camera or not? And then also, what additional features should we be restricting or allowing? And the vast majority of those settings, you can script a lot of these things, but a lot of them are delivered by way of config profiles, which we're quite familiar with. They do look very similar when they're deployed as legacy profile declarations. And MDM provides us remote and delegated access to things like the ability to lock or wipe a lost device, like a private user might do on their privately owned device with Find My. You have control over things like firmware passwords and recovery lock to prevent low-level access to parts of the OS that you don't want people to modify. And by now, because this is JNUC, you've heard a lot about legacy MDM versus declarative device management. So I wanted to talk through how DDM actually adds to your layers of security. And you might think outdated slide. Jeremy told us it's the present of device management, so please excuse the out of date there. You might think a configuration is a configuration, a restriction is a restriction, there's no meaningful difference, but there are actually some meaningful differences depending on which configuration we're talking about with declarations. So for one thing, clever end users with admin rights can often find ways around certain managed limitations. But what we're finding is with declarative device management, those options are quickly diminishing as Apple builds more functionality into this protocol. So as admins, we are historically very familiar with the idea that the most restrictive setting wins when we apply it to a device management context. If I deploy a profile that requires a 10-character passcode and a profile that requires an 8-character passcode, the more restrictive one, the 10-character passcode, is going to win. Increasingly, what we're seeing is that the most declared setting wins, even if the client behavior would default to something else. So I'll focus specifically on service configuration. With declarations, you can control access to the low-level services on the Mac that not even local admins can modify. So for example, you could lock down the sudoers file so that no unauthorized changes are even possible to apply for a user looking to elevate their privileges. You can prevent SSHD from starting remote shell access. You can prevent unauthorized web services. You can simply declare these things are off limits, can't change it. And the way this works is that you provide an asset that the Mac downloads from a secure location and verifies against a declared file hash. The Mac expands that asset in a local tamper-proof location, and that methodology, the idea of the tamper-proof local asset storage, also applies to another configuration, and that's about background task management. So as an admin, you can define scripts, apps, and configuration profiles configuration files, that the Mac will acquire and then store locally. And they can be referenced later, and even the local administrator can't modify or delete them. So the most declared configuration wins. During Jamf Nation Live spring events, we kind of put forth the idea of this could be a way to have a self-heal methodology for like the Jamf binary, that kind of thing. It does give you other options in regard to enforcing local security agents or even crafting that self-heal methodology. You do have end users probably get creative about trying to remove management when it gets in their way. And of course, declarations allow for enforced software updates, which is one of our favorite things that not even creative end users can avoid forever. In fact, I just saw in the 26.1 beta 2 release notes that the not now option, when you've reached the final deadline for your enforced software update, has been removed. So you really can't avoid it anymore. And of course, OS updates aren't the only risk. Apps get patched for security vulnerabilities all the time. And the Jamf app catalog can definitely help with hundreds of the most common app titles so that you don't have to fuss with Composer to patch a browser for the 5th time this week. And we're working on additional automation and integration of app patching workflows with blueprints. So take a look at that when we have that available. I'm going to take a little bit of a digression to talk about passwords, because they're terrible, and it causes a huge amount of pain for us, for our users, help desk teammates, and can pose a major risk for our organizations if the wrong Post-it note makes it out into the wild. So there are a few specific events in device usage that make this particular pain particularly apparent to us. The first one is enforced expiration and those reset notices. Even the guy who initially proposed that passwords should be reset periodically has recanted since then. Forgotten passwords not only cause problems for end users, but pose the opportunity for social engineering against help desk, like, no, I'm totally Katie, reset my password. And I'm gonna focus on that last one on the screen, which is device provisioning, because if we start there, we can actually make the other events a little less painful. So on a Mac, of course, you have to have a local user context. Your end user needs to be able to boot the computer, authenticate at the file vault screen, and reach the desktop to do their job. And creating that local user account by default is quite easy. The Mac really wants to do it during Setup Assistant to handle that for you. And creating that local user account with a password that either matches some directory service credential or at least meets your organizational complexity and expiration requirements, that's been a huge pain for a long time. You've probably heard of a tool called Jamf Connect. That's why we did it, because this was not a fun time. Apple, you heard it yesterday during the keynote, but Apple has been evolving Platform SSO for the past several years. It used to be Enterprise Connect, and now, of course, it's meant to improve both the provisioning process and enhance the security of local accounts that are created based on cloud identity provider credentials. And so I'm representing this particular security layer as kind of like a little bit of we'll call it a train between the Apple's basic services and then the managed identity options on a device enrolled with MDM, because the new Platform SSO workflow is a little unique and it's worth talking through. So based on cloud configuration defined by the MDM at device activation, Apple Business Manager, Apple School Manager, your Mac will be told to go download a Platform SSO app from the developer or app bundle that you define with the configuration that you define. And from there, the device and user registration happens according to your IDP requirements. And that's all prior to the device actually being managed. It's very fun and bootstrappy. You're using identity as the gateway to allow management, and then applying that identity as the local user account. And then over the lifetime of the device, you can use that identity to ensure that those SSO features actually reduce user local authentication events over time. And you can also use multi-factor authentication. So in conclusion about Platform SSO, passwords kind of stink. So if we use them less, maybe our outcomes will be better and our end users will thank us. Speaking of end users, it would be a missed opportunity to not consider them as assets in our security framework. So I'm going to talk a little bit about a different representation of layers. This one's pretty common out in the industry, the Open Systems Interconnection model, 7-layer model of how data and architecture communications work in computer networking. And because we're talking about raw data and how that data is moved around, how it's presented to the user, each one of those layers actually represents a different kind of opportunity for attack. So in the network layer, you can actually intercept data in flight and inject something else and get a man-in-the-middle attack. And if we extend that model a layer up, most people think of layer 8 as the human. Now, either that's the end user, or it could be the politics and processes around that user. And let's be honest, it's easy to be cynical about layer 8 and to treat the person using the device as a liability. But that's really only true if the end user doesn't have the tools and visibility to make good choices about their security behaviors, which is why we're such fans of Self-Service Plus. If I borrow layer 8 from the OSI model, bring it over here as a layer in my model, you can talk about Self-Service Plus as a multiplier for good security practice in your organization. So the more information that you give your end users, the more tools you provide for safe remediation, the less work you ultimately end up having to do. And that's why Self-Service Plus has improved notifications and visibility into security alerts and privilege elevation options. That's why that's a legitimate extra layer of security in the management stack. And they don't require you to go looking for tools or scripts across the community, which are great, by the way, but now you don't need them anymore. Of course, that said, in Jamf Pro in particular, here's a throwback. Anybody remember that graphic? You do have a ton of flexibility in regard to local Mac scripting with the Jamf agents. So basically, you can create custom inventory fields that report on pretty much any old value that you want. And then you can build workflows to remediate or report on those values. And if you were so inclined, you could even write hundreds and hundreds of lines of script to apply security benchmark settings in an incredibly tedious and manual way, like I did many years ago. Please don't do that. Please use compliance benchmarks instead. And compliance benchmarks is definitely your easy button to basic security baseline. It's tailored to your organizational needs. We've got multiple standards available to you, including NIST. You can define organizational specific values. So if certain fields don't apply to you, disregard them. If you would like people to be able to use Bluetooth, great, go ahead. If you need to change the default for screensaver activation, you can absolutely do that. You can also start with an audit or monitor mode before enforcing any changes that might actually disrupt things for your end users. Okay, we have been climbing for a little while here. We're going to set up camp, because I love this metaphor, and we're going to do a quick review before we tackle the last summits. Now, we've talked through the fundamental focus on security across Apple's entire platform as a combination of hardware design, secure software delivery, runtime security processes, and ongoing service enhancements. We've talked through how Jamf management elevates that out-of-the-box security experience by allowing you as an admin to report on and enforce basic settings, things like system integrity protection and file vault. And then we add in more advanced values like managed device attestation. And we allow you to build your own security framework with custom inventory and scripting, as well as the industry standard benchmarks that we provide via compliance benchmarks. So we've got the tools to help you keep your devices up to date. We've got the tools to empower your end users to elevate their privileges when they need it for a specific task. They can patch their own apps, and they can also be alerted to their own security behaviors. And if that were the end of the journey, that'd be pretty cool. But we still have a couple more peaks to conquer. So I'm going to start with one of our newer features, which is Jamf's network relay service. And it uses the values reported in managed device attestation in device inventory to ensure the device's legitimacy, then allows for microtunnels to critical resources as soon as your device onboarding, if that's what you like, potentially well before your VPN has actually been installed, activated, and logged into by an end user. So basically, we are just kind of offering ways to fill gaps, because with our coworkers working pretty much anywhere, we can still add more security to those remote connections in contexts where the traditional infrastructure just might not work. I'm thinking about most of us traveled to be here. Some of us used internet on the plane. Some of us are trying to connect in a hotel. Those contexts are not super VPN friendly. So this can help. It means we're not stepping on any existing infrastructure. And earlier I talked about the big hammer for device security that's built into Apple's platforms. That was lockdown mode. And I mentioned that that configuration is a trade-off. You limit risk exposure by disabling some of the more convenient and delightful features of the Apple device. For mobile users in an organization who are high profile or particularly sensitive, we also have a similarly high-powered Jamf option, which is Executive Threat Protection, which provides profound visibility into mobile device behavior and risk, as well as providing advanced attack detection and response capabilities. There is a trade-off, and it's pretty minor, but basically you have to connect this device to the scanner app prior to its deployment. So you do need to do a little proactive planning rather than reactive. Honestly, it's a trade-off worth making if this is something that concerns anybody in your organization. But awesome tooling. And because the final climb in front of us requires a bit of discipline, we're going to talk about Jamf Protect briefly here. But it on its own provides a number of layers of protection. So we integrate with Jamf Pro, get the Jamf Protect agent deployed on our managed computers, and then we start getting fancy. Much like compliance benchmarks, when you start off with monitoring, you kind of pull in the analytics into Jamf Protect. So we just start soaking up data with rules that detect suspicious user behavior and malicious system activity. And that's all based on the MITRE ATT&CK framework. Much like how we offer NIST and CIS, we're just continuing to iterate against industry standards. And on the Mac, we get threat prevention that massively augments Apple's onboard XProtect tools to detect, block, and quarantine malicious processes. And we have powerful options for network and web threat prevention, as well as internet content filtering, app vulnerability management, and usage controls to keep our users from wandering into dangerous places or from using dangerous apps. And all that data that we're pulling in, we can ship it off to a SIM for long-term storage or processing. Then we pack up all of those features in a plan with Jamf Pro to execute for the last leg of our journey. And finally, the last bit of the metaphor I'm going to use, that's probably a lie. Our guides from base camp to the peak are my colleagues at Jamf Threat Labs. And their work directly informs our products in malware detection and risk assessment, but they also serve the market in regard to thought leadership and knowledge and occasionally book deals, which is super cool. You should definitely check out Jaren's book. And while we're at the peak, we definitely want to pull out our iPhone, and with Self-Service Plus installed, once that's available, we'll have the key features of Jamf Trust that will enable mobile threat defense and data policy. And that'll be especially helpful because I bet roaming is pretty bad at the top of the mountain there. So we're going to take a minute, we're going to enjoy the view, and think about what we should take back with us. First off, you should really read the guide. The Apple Platform Security Guide is great. It's an excellent resource, and it should be something that's kind of just available to you. You can print it to PDF or just read it straight off the web. My second point is manage to secure. You get devices into management, and you immediately can take advantage of quite a few management features to secure and report on your device condition and actually remediate any risks that come up. But also, just to add an extra bullet point to that, you should secure to secure. We have a lot of additional tooling that would really help to build up your overall story. And that also moves on to understanding your risk. You want to report and pull in just this basic stuff that you should kind of have on speed dial at pretty much any time. So things like the distribution of OS versions in your environment. I talked to some admins just yesterday who are still running macOS 14. Yeah, okay. There's going to be known CVEs for older OSs and also for apps. So make sure that you've got visibility into what's going on in your environment. You can use blueprints to update all your devices and lock down your Mac, especially with in regard to service configuration and background tasks. You can use compliance benchmarks to apply a baseline of different flavors depending on the standards of your organization. And you can prepare to win a lot of arguments with your Windows colleagues. Jamf Protect multiplies the effectiveness of XProtect, which of course is Apple's native anti-malware scanner. Jamf Protect with the endpoint detection tool is going to be just that much more effective to help you understand the current risk and flavors of behavior in your environment. Your users can be assets to your security story with Self-Service Plus. And of course, don't forget the big hammers. That's lockdown and executive threat protection that will both provide significant visibility and potentially just straight up reduce risk out of the box. And then finally, that last one is pretty important there. Our AI assistant tool is going to let you kind of combine the power of the Jamf platform. So I mentioned things like, let's find out how many risks you have in your CVEs that are open in your available operating systems. AI Assistant can generate a report for you that will actually help you see that risk holistically across your environment, and then you can create an action plan to solve it. We are very close to time here, but I wanted to say thank you for attending today, and thank you for coming to JNUC. If you wanted to ask questions, again, we're close to time and the room's got to recycle. I will be in the expo hall this afternoon and also tomorrow morning, and I'd be very happy to chat there. So thanks very much.
Awesome. Thank you again, Katie. As she shared, meet her outside or even at the expo hall, correct? Enjoy the rest of your day. Thank you all for joining our session.